Hello and welcome. In this lab, you will manage revisions of the REST API server using Kubernetes deployment. Let's get started. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Check the contents of version 2 of the backend deployment and compare it with version 1 of the deployment. I have them open side by side to make the comparison easy. Let's start with the similarities. The deployment name is the same, Fibonacci backend deployment. Labels, selectors, and replicas are also the same. Now let's look at the differences. Check the annotation section. The annotation value is Fibonacci backend v2, while in version 1 of the deployment it was Fibonacci backend v1. The annotation is an identifier to the deployment, and it will be useful when we check the deployment history later in this lab. Check the args defined in line 26. The container oshokri/Fibonacci backend takes an optional parameter -v to specify the REST API version in the Fibonacci function's response. If no value is passed, the version defaults to v1. Check how this logic is implemented in the REST API Flask code in api.py at line 11 and lines 72 and 73. When you specify an args value in a Kubernetes container spec, the args replace the cmd instruction of the container. To understand what that means, check lines 11 and 12 of the Dockerfile for the container. The entry point Docker instruction is the command that the container will run. In this case, it's python 3 -u/scripts/api.py. The cmd Docker instruction appends parameters to the entry point. In our Kubernetes YAML manifest file, we specified args -v v2.o, which results in a Docker instruction cmd -v v2.o taking effect. This will be the case whether or not the cmd instruction in the Docker file was commented out. This makes the container run the following command: python 3 -u/scripts/api.py -v v2.o. In short, the YAML file of the v2 deployment runs the container in a way that makes it print v2.o as the version in the Fibonacci function result. Remember, you containerize the backend into your own container image in the Docker section of this course. If you wish, you can edit the deployment YAML file to use your own image of the backend here. Launch your terminal and make sure you are at the Fibonacci sample/k8 directory. Let's review the deployment you created in the previous lab. List existing deployments using this command. The deployment is up and running with 5 replicas. List the existing replica sets with this command. The deployment owns this replica set, which has 5 replicas or pods of version 1 of the REST API. Launch this link in the browser to figure the Fibonacci of 15. The result shows version v1.o. Run this command to roll out version 2 of the deployment and monitor the deployment status right after. You can see from the terminal output how Kubernetes is gradually scaling up the replicas or pods of the new deployment up to 5 replicas. You can also see how Kubernetes gradually terminates the replicas of the old deployment. This is because our deployment is using the rolling update strategy. Refresh your browser and you will see version 2.0 now. Let's list the existing replica sets. The deployment now owns 2 replica sets. One is the currently active with 5 replicas of the v2 pod. The other is the one from v1 and it is scaled down completely to 0. It does not have any replicas. Run the describe command to get more information about the deployment. Note the deployment strategy being rolling update. Also, check the new replica set having 5 out of 5 replicas created. Finally, check the events section which logs information about the scale up and scale down actions that happen to the replica sets. Run this command to list the deployment history. You get a nice list of deployment revisions, each one of them having a change cause that came from the deployment annotation. Let's say you found a bug in version 2 and you want to revert to version 1. Simply roll back the deployment to version 1 using this command. Watch updates printed on the terminal showing gradual scale up of the version 1 pods and gradual termination of the v2 pods. Refresh your browser and you will see version 1.0 is back. Let's list the existing replica sets again to see what changed after the rollback. The replica set for the v2 replicas is scaled down to 0 pods, and the replica set for the v1 replicas is scaled up to 5 pods. Now check deployment history again. You see that the latest revision is 3 and it is version 1 of the Fibonacci backend. The revision 1 is gone because it was identical to revision 3. Kubernetes deployment history keeps only one revision entry for a specific deployment configuration. Finally, let's list the events that happened to each replica set so far. We will use the power of the grep command to zero in on the events that took place to each replica set. Type this command and copy the ID of the version 1 replica set from above. This will list the events that took place to the version 1 replica set. Repeat the same command, but this time provide the ID for the version 2 replica set. And this lists the events that took place for the version 2 replica set. Let's do a progress check of the application at this point. In this lab, you have rolled out a new version of the REST API server, then rolled back to a previous version. You used a rolling update strategy to update the pods gradually, thereby ensuring your service will have minimal or no downtime. That's it for this lab. Thank you and see you in the next lecture.